For this next exercise, we're going to go ahead and take the same definition that we've been using for the image sampler, but instead of pixelating the image or creating a set of fins or an undulating surface, we're going to go ahead and use it to mimic an existing example known as the three shadows gallery. So I'm going to go ahead and bring up an image over here for you. And here you go. So you can see here, this is a brick wall that the bricks are actually pushing out of the surface or pushed back in to create a pattern. And the pattern is just a simple kind of lotus pattern, kind of more cloud-like, where the darker bricks stick out further and the lighter bricks are pushed back further. But you'll see the effect on there is that the patterning appears on the facade of the building as a whole. And you can see here is the actual undulation of it. So we're going to go ahead and use the example that we've been working off of and create that brick push-pull effect. And to do that, we're going to go ahead and kind of dissect this image sampling definition a little bit. So the first thing I'm going to do is I'm going to do a save as. Make sure that I have this saved as a different file name. You can call this your brick push-pull, or whatever you want to call it. And we're going to go through here and dissect this a little. So without getting too far into this, we know that the result is not going to be a surface anymore, but rather it's going to be a set of bricks. So I'm going to go to the end here, take my surface and delete this out of here, and we're going to use the box component to control those bricks. So we're going to go underneath our surface, primitive, and box center. This is the same component we used when we did the Eisenman definition. And this just needs to know the location, the base plane, and XYZ point for the brick. It's brick's X, Y, and Z dimension within there. Now the X, Y dimensions are going to play a lot, X, Y, and Z are going to play a lot with the spacing of the bricks itself. So what we want to do is we're going to go ahead and go back to the beginning here. You see we have a resolution happening here. We're going to dissect this a little bit further and not work off of a resolution, but work off of an overall image size or brick pattern size. The first thing we need to do is dictate the dimensions of a brick. And I'm going to go in here and drop in a panel tool. And a standard brick is 4 units by 4 units by 8 units. So we're going to go ahead and just say there's my brick width. Let's try that again. There we go. Okay. And we're going to also create one that controls our height and our depth. Change that to 4 units and call this my brick depth. And change this to 4 units and my brick height. There we go. Okay, so now technically that's going to become our cell size. We're not going to worry too much about depth for right now. The depth is the z-axis. That's only going to control it, but to control the grid, we actually need to control the x and the y. We're no longer going to be able to use a square grid because we have a rectangular brick unit, so we need to use a rectangular grid. Let's go ahead and swap out that rectangular grid. Go to vector, grid, and put in a rectangular grid. There we go. Okay, we don't need the square grid, so we can delete this out of there. The starting point can still be 0, 0. The size in the x direction will be our brick width. The size in the y will be our brick height. And then we still have the number of bricks in the x and the y. Now, it's important that we know the image size because, or the final surface size, because that's going to control that image domain. So what we want to do is we want to tell it how many bricks we want to have in the x and the y, and be able to divide that out to know how many, the overall size in the x and the y, divide that out by the brick dimension here. So what I'm going to do is actually I'm going to delete all these out of here for a moment. Let's put in a slider, so parameters input number slider. And this is going to be our wall dimension. Wall width in inches. And we're going to double click and change the parameters, integers, and no less than 1, and then maximum of, say, we're going to go ahead and do this in inches, so let's just do 1,000 for now. There we go. And we'll just put that at about 500, just in the middle, like so. So that'll be our overall wall width. And now what we want to do is do the same thing for the wall height. Like so. Now, to figure out how many bricks we need or how many cells we need in the width direction, the x direction, we need to divide our overall brick wall width by the brick width to tell me how many bricks that takes. So let's go underneath our math operators and do a division. We want to divide our wall width of 500, divide that by unit of 8. And actually, to make life simpler, let's make this 400 so it divides out perfectly. And we'll do 400 in that direction as well. There we go. So now 400 divided by 8 tells me we need a total of 50 cells in the x direction. We're going to do a similar operation, but we're going to take our brick height, run that into the A, the brick height into the B like so, and that tells me we need 100 in the height direction like so. So there we go. If I measure this now, the distance for the full width should be 400. The distance for the height should be 400. If I go ahead and adjust this, I can make it larger or smaller. So let's just leave that at 400 for now, like so. Now remember, we always have to match the domain of the image to this height and width. We don't need to flip anything for this point, but we can run the points directly into our image sampler. We can double click and say 0 to 400 and 0 to 400. Hit OK. And now we've sampled them at each of those locations. Now, if we simply use this as a move value, so remember the values that we are getting out of here are going to be between 0 and 1. We could simply move this as use this as a move value. Let's hold off on this remap and let's just bypass that for a moment. Run that into our move z. The points we want to move are our grid points. And there's our actual move vector. Okay. And the thing we want to move is going to be the brick geometries. We have to construct those geometries first. So the bricks are going to be located at each of the grid points. And then their x, y, and z values are coming from here. So instead of wiring all the way across, let's put number components. We know that those are going to go parameters, primitive, and number. I'm going to go call this my brick width. Make this a wireless receiver. Copy paste 2 more times. One will be my height, and the other will be my depth. Wire that into each of the corresponding panels, like so. Bring these over and run them each into your X, Y, Z. Now remember, we're using a center box, which means that each of these things are going to be twice as tall, twice as wide, twice as tall, and twice as long. You can see that they overlap, okay? And actually, we're going to have to go ahead and figure out, oh, we don't have anything. There we go. Let's try that. There we go. So now they all overlap. We have to divide these all out. So we need to put the expression of, let me move over here so you can see my expression. There we go. X divided by 2 for each of these inputs. And that'll go ahead and make sure that the bricks do not overlap with their neighbors and that they're the proper width, depth, and height. Like so. So now you'll see you get bricks that touch each other but do not overlap. These are the objects that we're going to use to move. Okay, so then we're going to go ahead and we've moved the points. The moved points, the moved points are the objects that we want to apply the bricks to. Okay, so we're going to go ahead and use, instead of the bricks all being on the base grid, we're going to use these moved grid points up there. And I'm going to go ahead and bring this down a little bit, like so. And you'll see that there's a little bit of an effect. It's hard a little bit. There you go. You can start to see a little bit of an effect. But this is where our remap comes in because we don't have quite enough magnification happening. So we're going to go ahead, instead of going straight from the image sampler, which only lets us move it between a value of 0 and 1 unit, we're going to remap it to be able to move it further. Okay. So what we're going to do is go ahead and use these remap values as our move fact, and you'll see it becomes even more increased. Okay, and we can use this max displacement and even increase the value from 0 to 20 and have more displacement to create those undulating bricks. Now this is great except for the fact that our wall does not lay down on the XY plane. We need to orient our wall to be vertical. A couple things we have to do that. First off, let's organize ourselves. Let's group all this stuff. So I'm going to go ahead and add these items to that group. So this is all about moving our points and creating the boxes. This is all nicely grouped. And this is all about our rectangular grid and the original brick dimensions. So let's go ahead and group this. And we can leave the image sampler kind of off on its own. It has a group around it, doesn't necessarily need it. There we go. So what we need to do is actually make a vertical grid, not a horizontal. To do that, we have to change the plane that the base grid is on. Right now it's on an XY plane. We want this to be on a XZ plane. So what we're going to do is go to Vector, Plane, and find our XZ plane. We're going to go ahead and use that as our plane to make this on. So they went ahead and moved it vertically, but we no longer get our image applied on there. Why? Here's the issue. The points now, if I go ahead and drop these in a panel tool, you'll notice that the points all have, let's scroll down here, X values and Z values. They do not have Y values. All the Y values are 0. Why? Because they're all stacked along the X axis. None of them are out on the Y value until we actually move them. Okay, so what we want to do is we want to sample not at the image sampler, not at the X and Z locations when they were laying down. We want to use the excuse me, let me step back, I apologize. We don't want to sample the X and Y values of the bricks. We want to sample the X and Z values of the bricks. However, the image sampler only lets us use an X and Y domain. Okay, we have no values in our Y, therefore it's not going to work properly. What we need to do is swap the Y for the Z values. To do that, we're going to put a little space in here. I'm going to leave that panel tool so we can see what's happening a little bit later on. Put a little space in here. We need to deconstruct the points and say, okay, what was once our Z values now are going to become our Y values. To do that, we're going to go underneath Vector, Point. We want to use a deconstruct point and a construct point. We're going to deconstruct the existing points. We like the X values, so that can stay. So we'll just wire the X into the X. But now we want the Z values to become the Y values. So we're going to take the Z values and turn those into Y values. We don't have to swap these. You'll see what happens is our surface goes from being vertical, laying back down onto the XY plane. That's good because now we have, you'll see X and Y values and nothing in the Z. X and Y values, nothing in the Z. Basically this column and this column just flipped places by doing this swapping here. That's perfect because again our image sampler is looking for an X value and a Y value. There is no Z domain. We can't use the Z. So now that we've done that, we can run that in and we can use that as our displacement. Now the other thing we need to do, we can group all this together because that's part of an operation. Perfect. The other thing we need to do now is we don't want to move them vertically, we want to move them along the y-axis. So we no longer want to move vertically in the z, we want to move laterally in the y-axis. So this is going to swap from being a z vector to being a y vector. So again, vector, vector, we want to move them along the y-axis. So go ahead and just rewire, and we're going to replace this z with this y, like so. We're going to go ahead and delete that out of there. Let's add the Y as part of the group. Perfect. Let's turn off some of these older components. And there you have it. Now you can start to see how that image is showing up. And the bricks now are moving along the Y-axis. The surface is vertical on the XZ plane, but the bricks are moving along the Y-axis. And again, we have this kind of magnifier to make it happen more or less within there. Okay, so the next portion of this definition was we're going to go ahead and change this from being a stacked bond, and to clarify, a stacked bond just means that bricks are vertically stacked on top of one another, to being a running bond, and we'll do that in the next definition.